Okay, so ladies and gentlemen, my name is Wojciech Spivok. Thank you for joining us. Thank you for coming. I would first like to thank Marko Vidak, Brane Leskošek, and Jure Dimec from Elixir Slovenia for making this webinar possible. And I will start with slides. So I will quickly upload slides, which should go here. Do you see the slides? So I would start with the method called Metadynamics. Metadynamics is an extension of molecular dynamics simulation. And the problem of molecular dynamics simulation is that if you want to study some molecular processes which take place in millisecond time scales, you have to do millisecond simulation, which is computationally extremely expensive and often impossible. So there have been many methods developed to accelerate simulations, and one of them is metadynamics. And metadynamics disfavors states of the system that have been already visited during the course of the simulation. So this acceleration is done by a bias potential. This bias potential is defined in a space of usually either one or two so-called collective variables. These collective variables are some variables which describe the state of system, and you have to specify them at the beginning of the simulation. And this bias potential is composed of hills which accumulate during the simulation, and from these hills you can calculate or predict the free energy surface of your molecular system. And I would like to also sing happy birthday to Plumed package, which is the most common metadynamics platform today, and there was 10th birthday couple of days or weeks ago. Beside Plumed, which is a program by which you can run metadynamics in many molecular simulation programs, there is also a quite new project, Plumed Nest, which is a repository where you can upload your input files for a metadynamic simulation, and others can use them. I would briefly introduce R program. R started basically as a statistical package, but nowadays it can be used more or less in all different fields of science. And there are more than 14,000 different packages available in R. One of them is Metadynminer. You can download them or install them from comprehensive R archive network. There is also quite a nice environment for doing R calculation, nice graphical interface called RStudio. Personally, I don't use RStudio, but I know many people who use RStudio and are very happy with RStudio. And there is also quite recently Microsoft R, because there was some company which was provided some partially open source, partially commercial version of R with some services, and this company was acquired by Microsoft, so now you can use also Microsoft R. If you want to use Metadynminer, you can install it, and the installation is done if you open R and you type this command install.packages, and in quotes and in brackets there is Metadynminer. And this will do all the job, so it will download and install not only Metadynminer, but all required libraries. And once it's installed, you can switch it on or invoke it or load it by a command or by function library with a parameter Metadynminer. Metadynamics produces some hills positions, which are, if they come from Plumed, are stored in a file which is usually called hills. And you can load this hills file using the function read hills. You have to specify either if it's on your computer, some local path, or if it's at the internet, you can specify internet address, and this loads a hills file and stores them in some object. In this case, I called it hillsf. At this point, it's also necessary to specify periodicity. So if there is some collective variable is periodic, such as torsion, you have to specify it here by parameter PER, per like periodicity, and here it's set to true. The T stands for true, and this C function is like concatenate, so it makes a vector from values. So it will make some logical vector with two values, true. And beside this, there is some pre-loaded data set. It's for alanine dipeptide, one-dimensional and two-dimensional free energy surface with made by Metadynamics with one or two collective variables, either phi angle or phi and psi, Ramachandran angles from alanine dipeptide in water. So if you type ACE, ALA, and ME, it will show you that this data set is here, is there. You can sum hills files, and you can also make some summary, so it will print some extra information. You can plot hills file, which plots evolution of collective variable as a function of time for one-dimensional, and scatter plot of CV1 versus CV2 for two-dimensional metadynamics. And you can also plot heights of hills by function plot heights, which is useful for well-tempered metadynamics, which is the most common variant of metadynamics right now. And it will plot you the evolution of heights of hills. The most important part is of like some summation of hills to calculate the free energy surface estimate, and this is done by function FES, F-E-S. This function uses quite a fast bias sum algorithm, which my colleague Petr Hošek has developed. The idea of this algorithm is that instead of evaluating Gaussian function for every hill, it pre-computes single Gaussian, and it just shifts it and sums it. And it's suitable, therefore, only for simulation with constant widths of hills. If you have variable widths, or if you want to be sure and you want to explicitly evaluate Gaussian for every hill, you can use much slower variant, which is called FES2. And the result is very similar. You can also specify time range, so you can sum, for example, first 100 or last 100, or somewhere in the middle, some hills from the hills file, and you can specify resolution. Once you calculate the free energy surface, you can add, subtract constant value, you can multiply it by constant value or divide by constant value, so you can easily, for example, switch from kcals to kilojoules or something like that. You can add or subtract two free energy surfaces, and you can calculate minimum or maximum. So, for example, if you have some free energy surface and you want to change it to start from 0, from the global minimum, you simply type the name of the free energy surface minus a function min with the same argument, and this will calculate the free energy, or this will convert to free energy surface starting from 0. And you can plot free energy surface by function plot, where you can specify, for example, a range of different various axes. You can specify different color schemes. If you don't like colors which I have chosen, you can use whatever color schemes you want, and it's also possible to add color scale. You can also identify minima by function FES minima. When we were developing this function, we wanted to make it as simple as possible, or as practical as possible. So, for example, if you have some free energy surface with a huge number of little minima, then it's not very practical to get thousands of minima. So instead, this function somehow separates the free energy surface by some grid into different sectors and calculates or finds the minimum in each sector. So the number of minima is limited, which is, in my opinion, quite more practical. You can also make a summary function, which provides you some, for example, population, prediction of populations, and you can also add some, I call it fake minimum. So, for example, if this function fast minima fails to find your local, your favorite minimum, or if, for example, you want to add some reference value which is not really minimum, like some plateau, you can add it as another minimum. And this function plot, when applied on minima, gives more or less exactly the same plot, but there are letters A, B, C, D, E for individual minima. It's not very well visible, but if you try it yourself, you will see it better, or you can change color, change size, etc. You can also calculate free energy profiles for evaluation of convergence of metadynamics. So this will take the global minimum as a reference, and it will calculate evolution of all other minima versus the global minimum. And when you apply and then you can calculate the free energy difference, and you can make some estimate on convergence, and you can also plot it by again by function plot, which gives you such a line plot with individual minimas depicted in different color. Beside that, we have some other functions. So, for example, you can convert two-dimensional free energy surface into one-dimensional free energy surface. This is done by conversion of free energies to populations, and then these populations are integrated along one of CVs and then converted back to free energies. For this, you need to specify temperature. And there is also notch elastic band function, which can identify for a selected pair of minima the shortest path, as you can see on this image, like the pathway between minimum A and minimum D. And that's all about different functions. So I would like to shortly explain some like tricks and tips. So, for example, if you want some nice picture with high quality, you can use some function for saving figures. So, for example, PNG for PNG figure, but there are similar functions for other figure formats. And you can specify, for example, this specification here produces figure with 8x8 in a size of 8x8 centimeters with a resolution of 600 dpi. And so it's quite a publication quality figure. Quite easily, you can also make a movie. So if you calculate the free energy surface, for example, only for first 100 hills, and plot it, and then you make a loop in which you calculate a free energy surface on another 100 and another 100, and you sum it up and plot it in each cycle. Then this would generate 300 images called snap 0001 to snap 0300.png, and using some software for making movie, you can concatenate it and place it on YouTube or to article or wherever you want. I would briefly mention some plans for future. So we have had already some feedback. So there was a request to make reading of free energy surface from plumed driver possible. So we will introduce it, and we also plan to introduce exponential and sum function on free energy surface. So this would make it possible to plot probabilities instead of free energies. And we also want to make some more flexibility for printing of scale, so color scale. So right now you can plot either free energy surface without scale or with scale, but this would make it possible to somehow place scale wherever you want with some R commands. We also plan to introduce some reweighting methods, and we are mostly interested in making some more sophisticated methods for calculating or assessment of convergence of simulation, because the method that we have that I have shown, it works that if it does not converge, then there is something wrong. But if it converges, that it does not mean that that the simulation is okay. So we want to first somehow combine hills with Colvar files, so hills position with sampling, because these files are often sampled in different frequency. Then we want to introduce some reweighting schemes, either simple Boltzmann or umbrella sampling reweighting, or more advanced metadynamics based methods for the one developed by Max Bonomi or Pratyush Tiwari. Maybe we will think about some kind of automated identification of border between minimas, which we will see if it will go well. And after that, we want to make all these functions to make some more sophisticated methods for assessment of convergence of simulation. Besides this, we also plan to make some kind of online tool, because we are aware that not everybody is happy with R. So idea is that there would be some portal where you can upload a hills file, and it will do all the analysis, and it would provide you some report. We have some prototype, just right now it's just offline, and we are working to make it available online based on the Galaxy tool. Galaxy is quite popular in bioinformatics, mostly in sequence-based bioinformatics, and it's some web-based tool where you can include different mostly command line tools. So, and inspired by a recent success of plumed nest, we also think about some variant of plumed nest, or something inspired by plumed nest, that people would upload their hills files, and this would generate some movies, some reports, analysis, etc. So that's all. I would like to thank my colleagues who have collaborated on development and testing of Metadynminer, Dalibor Trapl, and Mahina Sharipova and Isabella Horvačanin. Again, I would like to thank Elixir Slovenia for making this webinar possible, and Plumed developers, Plumed consortium, Plumed users for giving us material for Metadynminer. So thank you for your attention, and feel free to ask any question. If it's not possible to ask now, I feel free to contact me, or you can also use this e-learning system. There are announcements where you can post some question or comment or wish list or whatever. So thank you.